So last lesson we were learning about the fats and sugars group. We conducted a scientific investigation where we put some eggs, one in water and one in cola, and left them for 7 days. Now, it is Friday today, so your eggs in cola, if you were joining in with this, won't have been in for a week. These are some that I prepared earlier at the weekend in true Blue Peter style. So these ones have been in the jars for a week. You could just leave yours in your jars until Wednesday if half term, and then have a look to see what happened to yours then. I wonder if it's the same as mine or whether it's slightly different. So let's have a look at these eggs. It's been in water and looks pretty much exactly the same as it did before. I'm just going to brush it and see if any colour comes off on the eggshell. So as you can see, I'm being quite firm with the brushing. No colour change there. It looks just the same as it was when we put it into the water. Now let's have a look at the egg in cola. Ugh, it feels really sticky. Oh my goodness, look at this. So already here you might be able to see where the sugar in the cola has started to break down part of the shell. Can you see that? Oh my goodness, look at that. Can you see the cracks here where it's actually, the sugar is worn away at the calcium in the eggshell? Also, let's compare the colour. I'm just going to clean my hand. Compare the colour of those two eggs. It might look similar, however, in front of me they do look quite different. Let's brush this one and see what happens. So this is the cola egg. So as I'm brushing this one, oops, the shell is not very strong on this tool. Can you see where it's rubbing away some of the colour? So I'm going to go again. You might be able to see again, this is the staining of the colour of the cola on the outside of the egg. And all of this would be happening to our teeth. You see that difference in colour? Also, as you can see, it's quite flimsy, and I've already broken a little bit of that. Can you see where the colour has also started to colour the egg underneath? So we can see where that cola colour has gone through. So the sugar not only has destroyed some of the calcium, so this could be destroying some of our teeth because it's not being cleaned, it's also, the colours in it are discolouring our teeth, or discolouring the eggshell in this case. Also, it means that the teeth are not so strong. The calcium is breaking down so much more easily, so it's not so strong. So, after having a look at those eggs in water and cola, I wonder if your predictions were correct. Were you right with what you thought was going to happen? So if you've got your task sheet handy from earlier on in the week, you could write what you saw for the egg in water and the egg in cola, or you could draw a picture of what you saw. If you are working on paper, then you could just make a note of this in your book. So we just want you to write something down like, the egg in water didn't change at all, it was exactly the same. And the egg in cola, we saw that the sugar in the cola had cracked the eggshell. We saw that the colours in the cola had coloured the outside of the eggshell. And we learned that actually this means that for our teeth, if we don't clean our teeth and we expose them to a lot of sugar, it could lead to cracks and holes in our teeth. It could also lead to discoloration of our teeth, or our teeth going a different colour. In fact, the egg that was in cola did look a little bit like those teeth that had turned rotten. So let's start off with a bit of a learning recap. So we know about the different food groups. Tell me very quickly, what's this group called? Fruits and vegetables, what's this group called? Carbohydrates, what's this tiny group called? Fats and sugars, what's this group called? Dairy, and what's this group called? Protein. Brilliant. So we've already had a look at the dairy food group, and we know that they contain something called calcium. And we need calcium for three things, which are strong bones, strong teeth, and strong muscles, correct? We also have talked about fatty and sugary foods and the fact that they give our bodies energy. And we use energy to do 4 things. We use it to move, we use it to repair, we use it to grow, and we use it to keep warm. Definitely something that I am using my energy for at the moment. So we also learned that eating too many fatty and sugary foods over a very long time can lead to all sorts of different health problems, and we focus particularly on our teeth and keeping them healthy. We knew that some foods have natural sugars in them, and we know that some foods have added sugars in. Can you think of any examples of natural sugar foods? Can you think of any examples of foods with added sugars in? Which ones are more healthy for you, the natural sugars or the added sugars? Well done if you said it's the natural sugars. It is, because the sugar in those ones is found naturally, it naturally occurs, and that's good for you, whereas the added sugars, sugar is added in the making process of that food. So today we're going to focus on a different food group. I wonder what it could be. Perhaps you've already seen the picture, perhaps you've already guessed. It is the carbohydrate group. So this group is all foods that are made using grain. So things like wheat and barley, which is ground down to make flour, and then products that can be made using flour like bread or pasta. Potatoes is also part of this group, and so is rice. So why do we need to eat carbohydrates? Well, they give our bodies energy, and we use energy for 4 things. Which 4 things do we use energy for? Well done if you said to keep warm. Well done if you said to grow. Well done if you said to move. And well done if you said to repair. What I'd like you to do now is to complete task 1. It is a true or false. I'd like you to read the statements and then either tick true or false, or if you're working in your books, just write a T for true or an F for false. So the main focus of today's lesson is to look at something that is very important for making bread, and that is yeast. Who has already heard of yeast before? Well done if you have. If you haven't, don't worry, because you're going to be finding out about it today. We are going to be investigating. In fact, we're going to be science detectives. I know that you make excellent detectives, and I think that you're really going to find this interesting. So, what we need to do first is find out how bread is actually made. We're going to see how flour is made and then how the flour is used to make bread. Look out for when yeast is mentioned. How much can you remember about yeast at the end of the video?
How is flour made? We've been making flour for at least 6,000 years. Stone Age people took grain and crushed it between 2 stones. Although modern flour mills are very big and make thousands of tons of flour every day, the process really isn't that different. To make flour, you need grain. Most flour that we use for bread is made from wheat grain. We grow over 16 million tons of wheat in the UK. It's usually planted in the autumn, and it grows throughout winter, spring and summer, ready for harvest in August. The farmer harvests the wheat using a machine called a combine harvester. Then the grain is taken to the mill, ready to be ground into flour. Each grain of wheat is a seed, which would grow into a new wheat plant if it were put into the soil. The grain has 3 parts: the bran, which is the outside skin, the endosperm, which is the food store of the grain, and the wheat germ, which is the part of the grain that grows into a new plant if the grain germinates. A loaf of brown bread has all the parts of the grain in the flour. When the grain arrives at the mill, they take a sample to check the quality. If the grain passes the test, it's unloaded into the mill's storage area. The next job is to clean the grain that's just been delivered. They take out all of the straw, sticks and stones using these sieves. Then they blend different types of wheat together so they can make the right kind of flour. This is called gristing. The flour used in bread needs to have a lot of protein in it to make it soft but strong when it's baked. The milling happens in these machines, called plan sifters. The machines separate the different parts of the wheat using rollers and air bubbles, and this process creates the flour. The ground flour is then tested and checked for quality. Then it's transported to the bakery or to the shops, ready to bake your fresh loaf of bread. How is bread made? Bread is a very important food. Millions of people around the world eat it every day. And amazingly, the basic recipe for bread has been the same for thousands of years. You just mix flour and water to make dough and then bake. To make a loaf of wholemeal bread like this one, it's a bit more complicated. Soft breads like this have an added ingredient: yeast. This works inside the dough to make it rise, and so when it's baked, it's much softer. In this factory, they make thousands of loaves like this every single hour. The first job is to weigh out all the ingredients: flour, yeast, salt, water, and very small quantities of some other ingredients, like fat and vitamin C. Next, this machine mixes all of the ingredients together to become stretchy and gooey dough. Then, they divide up the dough into loaf-sized amounts. Shape it and put it into tins. Now it's time to let the yeast do its work and make the dough rise. They put the dough in a warm, damp place. This is called proving. Did you know that yeast is a kind of fungus like a mushroom? But yeast fungi are microscopic. That means they are so small you need a microscope to see them. Once the loaves have risen, they are baked in these big ovens. They have to get the temperature just right. These ovens bake the bread at 230 degrees Celsius for 22 minutes. They blow the air around the tins to evenly bake the loaf. When they are ready, the loaves are removed from their tins and left to cool for 2 hours.
Bread, crusty bread, bake it in the oven, the baker said. Bread.
Now they are ready for slicing. This machine does the slicing job. And then the bread is put into bags. Finally, the freshly baked loaves are packed up in these lorries and taken to shops all around the country, ready for you to eat and enjoy.
So what is yeast? Yeast is a type of bacteria called a fungi. A bacteria is a living thing. So we're humans, we're living things. Animals are living things as well. But this is a bacteria, something that we can't see very well that's all around us, and it's called a fungi. Yeast is a good bacteria. You might have heard that some bacteria are bad for us, and that's why we have to wash our hands to get rid of any bad bacteria that could make us poorly. But yeast is a good bacteria. Humans use it to make some breads. It's very difficult to see, but you can see it with the help of a microscope. If you have a look at yeast under a microscope, this is what it looks like. This is yeast when it comes out of a packet. So if you've made bread at home before, then you might have used dried yeast, and this is what dried yeast looks like. And then when you put that underneath the microscope, this is what yeast actually looks like. So now what I'd like you to do is complete task 2. There are some missing words for you to fill in. All of that information can be found on this slide, and there is a place for you to draw a picture of what yeast might look like underneath a microscope. If you're working in your books, you could write out the sentences and draw the picture of yeast. If you're working on the sheet, then you fill in the missing words. So, why is yeast an important ingredient for making bread? Well, without yeast, we wouldn't be able to make the kind of breads that we normally buy from the supermarket. And how does it work? Well, it works like this. Yeast needs energy to work. Humans need energy to work. We're all both living things, so we all need energy to work. Humans use energy for 4 things. Can you remember those 4 things? It's to keep warm, it's to repair, it's to move, and it's to grow. And bacteria is really similar. It needs energy in order to do those things. So, yeast needs energy to work. Where does it get its energy from? Well, it gets that energy from sugar. So when we make bread, we have yeast and we also have a small amount of sugar that goes into the bread to give yeast energy so that it can work. The energy from the sugar makes yeast work, and when it does work, it gives out the gas carbon dioxide, usually as bubbles, because within bread we've got liquids, so we often see the carbon dioxide gas travelling in bubbles up to the top, popping, and then the gas being released into the atmosphere. So what is a gas? A gas is something that's all around us that we can't see. We sometimes can feel gases because we breathe out. So when we breathe out carbon dioxide. Try it now. Try breathing out onto your hand. Can you feel the gas that is coming out of your mouth? So you might be able to feel some of that as it's moving. Have you ever filled a glass with a fizzy drink and put your hand over the top? You might feel the bubbles popping, and as they pop, you might feel small amounts of water hitting your hand, and that's where the gas is being released from the bubbles and into the atmosphere. There's another time when we often collect or hold gas, and that is when we're blowing up balloons. So if I blow into here, I will collect gas that's coming out of my mouth, and humans breathe out carbon dioxide as well as other things, so there will be some carbon dioxide in here. So that has now captured some carbon dioxide and it's trapped in the balloon. There are also other gases in there that humans breathe out, but we don't need to worry about those. So why is yeast so important for making bread? Well, we put yeast in the bread dough because it uses the sugar in the mix to get energy. This makes the yeast work. The yeast releases a gas called carbon dioxide. The carbon dioxide makes bubbles. This makes the bread dough rise and it creates a fluffy texture. So if we didn't use yeast, we wouldn't have a risen bread. So it means that our bread wouldn't be nice and fluffy how we get it from the supermarket. So that brings me on, do all breads need yeast? So if we have a look at these pictures, particularly in this white bread here, you can see lots of air bubbles. And this is where the yeast is working well. And the yeast has produced carbon dioxide, they've made bubbles, and the bubbles have kind of stayed in the texture of the bread to make it light and fluffy. You can also see that it's made this bread rise. That means instead of it being flat to the table, the yeast has made it tall like this. So we've got white bread, a bagel, and some naan breads. Which ones do you think have yeast in them? Or how much yeast do you think they've got in them? A lot, a little, or none? Make some predictions. The white bread does have yeast in it because it's a tall bread and it has risen. You can even see those air bubbles from where the carbon dioxide has been produced by the yeast and has made the bubbles in the bread. The bagel also has yeast in it because it's still quite a tall bread. We can't actually see the structure inside of the bagel, but it has got quite a lot of air bubbles and it's got a soft and fluffy texture. The naan bread only has a very small amount of yeast in it because it's much flatter. This is a stack of naan bread, so there's 1, 2, 3, 4, 5, 6 in that stack. They're much, much flatter, so they only have a very, very tiny amount of yeast in compared to these two. That's why this bread hasn't risen. It's very much a flat bread. The tortilla wraps, what do you think for them? Look how flat they are. Then we've got a baguette. Think about the baguette. Think about the texture of that. Think about how tall it is. And then we have a pita bread. Again, this one's quite flat to the table. So will it have yeast in or not? So the tortilla wrap has no yeast in it because it's a flat bread and it hasn't risen. The baguette does have yeast in it. It's got a fluffy texture inside. If you've ever tried baguette, you will see that it's got a soft, fluffy texture and it's got air bubbles in there too. You might even see some of the air bubbles that have baked on top of the bread. Pita bread has no yeast in it. It's a flat bread. So what we're going to do now is carry out a fair test. Now, a fair test is what scientists use to see whether something works or doesn't work. We are going to investigate what temperature is best for yeast to work. So a fair test means only changing one thing and everything else needs to stay the same so that we can see if it has an effect on our results. We are going to investigate what is the best temperature for yeast to work, and we are going to try 3 different temperatures: cold, warm and boiling. It's a little bit like humans, really. I wonder what we would prefer to work in. So let's recap what we already know. What does yeast need to help it to work properly? Yeast needs energy to work. Where does it get its energy from? It gets its energy from sugar. The sugar gives the yeast energy and makes the yeast work. The yeast then gives out carbon dioxide gas as bubbles. So we're going to change one thing, and the thing we're going to change is the temperature. We're going to try cold, we're going to try warm, we're going to try boiling. Everything else we're going to try to keep the same. We'll need to keep the same amount of yeast each time to make it fair. We'll need to use the same amount of cold, boiling and warm water. We'll need to use the same amount of sugar, the same size balloons, I'll explain what they're going to be used for later, and the same size containers. What I'd like you to do now is have a go at task 4. Note down what we will change and what we will keep the same. This is the equipment we're going to use. We're going to use some milk bottles to put the water in. We're going to also put the yeast and a teaspoon of sugar in the bottles. Once we've filled them with water, we're then going to need a way to trap the carbon dioxide to see how much is being produced. How could we trap the carbon dioxide that will come from the yeast when it's working? Well done if you spotted the balloons. We're going to put the balloons over the top of the milk bottle to hopefully catch the carbon dioxide as it is released. On task 4, now fill in the equipment list with what we will need. Okay, so prediction time. All good scientists make predictions. They think about what could happen and what they think will happen, and then they test it to see if they are right. So which temperature do you think will work best? Boiling water, warm water, or cold water? What do you think you will see? You can write or draw your ideas in the prediction section. We'll actually come back and revisit the results after half term. So if you want to try this experiment at home over the holiday, you can, as long as your mum and dad are happy for you to do that. And then after half term, in that first science lesson back, you can look forward to seeing the results.